Okay, so this is the Challenger River from Cyber Open Season 2. I'm going to be showing you how to do it real quickly. Now, first of all, I'm just going to download it and quick switch over to Ghidra. We're going to go ahead and import the file. It should be located in the Downloads folder, which we already had open, luckily. We're going to need to change the destination file name because we imported this once previously, but we can just go ahead and do river.river. We're going to go ahead to the analysis options now. It should pop up momentarily, and once it's there, we just go ahead and analyze. You can use the pre-selected options and then close out this summary. We can jump into the start, which is in every ELF file, and we should go to a start function that calls libc start main. That will indirectly call main, so we can jump into main. First thing we see is it appears to call the string length on our second argument. This second argument needs to be 39 characters long. Scrolling through more, there's a bunch of different operations that get performed, such as XORs. And it appears that now, at what appears to be the end, because you get a correct or wrong statement, is a memcompare. Memcompare will compare every byte in the file to the bunches of pseudo-random looking bytes up there in what appear to be an array. So what essentially I'm going to try and do is I'm going to try and get the correct statement by intercepting memcompare. First off, we can just go ahead and copy our river file into a temp directory for working on it, and we're going to chmod it to make it executable. Once we have the file, we can run it, and we can see that it is not like our tests. By using ltrace, we are able to see system libraries that are called, and we are then able to test a string of the correct length. I hit a bunch of digits because it's easy to keep track of how many characters there are when you have 10 digits. And it appears that it does a bunch of forks, closes the forks, and opens up pipes as well. So it's doing some complex processing, which frankly, I don't have the time to understand right now. So we're just going to go ahead and cheese this challenge. We are going to attempt to intercept the library calls that it does, specifically to call to memcompare. We can go ahead and call man memcompare to look up the Linux manual for memcompare, and we can see that it is attempting to do the following. We can copy what it has for the header, and we can just edit it to be whatever we want. We'll go ahead and save this as, how about override.c, and we can go ahead and fill out this function. Memcompare compares every byte one by one. So first off, we're going to need some kind of for loop. And the for loop is going to compare every byte, and once the bytes are compared, it's either going to return 0 if the arrays of data are identical, or it is going to return a non-zero number based on which one is larger. It doesn't overly matter which one is larger for our test, so we're just going to return 1 if they don't match. And we do this by first off casting these void pointers to character pointers. Cars or characters are essentially single byte elements in the C language. So we're just going to create a simple if statement with these two arrays being first cast to car pointers. Now, if they are not the same, we're going to return a non-zero number to show that these were not similar. Well, not similar, but however not the same. And we're going to now go ahead and import the IO library so that we can print the number of characters that match. And we print this so that when we run the program, we know how many matched. Essentially what we are going to try and do is we are going to guess one character at a time. If another character matches, we know that that last character was a correct guess. Now we can go ahead and compile our program, override.c, and it compiles. There's an error because it doesn't have a main function. That's okay. We just need to compile this as a shared library with position independent code, and we're going to output to override.so, so override shared object. We can then call our previous attempt at river, but instead of doing ltrace, what we're going to do is ld preload. ld preload is used in ltrace, but we're going to use it for our own custom memcompare. We are essentially inserting our shared object into the dynamic linker. And we see it appears to have matched 39. That's incorrect. Let's see if we... Yep. I copied the S1 variable without changing it to S2, which is not what we need at all. So now we see that none of my guess matches. So the first character is definitely not 0. We can now automate the guessing of the first character by creating a Python script. We can make use of pwn tools. So from pwn import asterisk, and we're also going to import the strain library. The reason we import strain is because it has the variable strain.printable. We can now iterate over all 39 characters, we can make a string to keep track of what we already know. And now for each character in string.printable, we are simply going to guess what we know already plus the next character. We need to pad it, so our guess is 39 characters long. We can do that by doing string if you multiply a string by an integer in Python, it simply copies the string. And we can do that to pad our guess. Once that's done, we can start a process using PwnTools. And as we start that process, we can simply call it on the River executable. And we have the first command line argument passed being our guess. We're going to need an environment variable to contain ld preload. And we're going to ld preload our override data, so as we did from the command line. So let's get the path in there. And now that that's done, we've now called the process successfully. We need to take what the process outputs. Specifically, we need to find whether or not we matched and on how many we matched. So we receive until match, and we're going to now do a kind of convoluted statement. We're going to take the integer, so an integer cast essentially in Python, of the next line that PwnTools outputs. And we're going to decode it with UTF-8 encoding, which is essentially ASCII encoding, which is what we want in this scenario. And we are going to then strip it of any trailing spaces or new lines. We can then print the number of correct characters we had. And if our number of correct characters is larger than our current index in the for loop, we know that we have guessed the next character. And we can then increase our string of known characters. And we can print it just so we have some debug information. And we are also going to break early because we know nothing else in that loop is going to be successful. We can then run it, and we get a lot of noise related to started processes. But we appear to guess the first character is T. We run it with silent, which will tell PwnTools to not print all the debug information. And now it should start guessing characters. We get T, capital H, free. That appears to be a word in LeetSpeak. We appear to be guessing the flag. It's going to take about a minute from here until it finishes guessing the flag. But it's relatively easy sailing now, and we don't need to actually reverse engineer the program. We simply cheese it. And that is how you cheese a CTF challenge. You ignore how they want you to solve it, and you solve it in an unintended but easier way. This could theoretically be solved faster by reading the Ghidra and understanding it, but I think you will really struggle to get it solved in under the 7 minutes and 50 seconds that this video is. So that is how you solve River in USI Robin Season 2. You can go ahead and check that, and it's correct, and we submit the flag. I've already found it, but that's kind of irrelevant.